This. Okay. Okay, so hey, I'm Viktor. I'm a postdoc at the SAIR lab at the Department of Engineering at King's College London. And this is our take, or a part of our take, on how to generate gestures based on different roles that people might exhibit, being the main agents or the interlocutors in a conversational setting. Yep, great. So the idea was that since we are transitioning from a monadic setting to a dyadic setting, it would be nice to kind of experiment with whether we can split a single end-to-end model into two separate models, one for the listener and one for the speaker. The idea behind this is quite simply that just based on like human behavior studies, the listener in a dyadic setting will usually be more passive, mostly rely on or mostly exhibit back-channel feedbacks such as nodding, the occasional that basically everyone is doing right now. Some head movement that signal affirmation, thank you, or confusion. Also, people, especially when in a one-to-one setting, usually exhibit some behavior asynchrony. So here is a video from the training set. So this is not generated by us.
Not superly, not every day I could do that, but every once in a while, if I was there working on a project, like on a weekend or something, I'd drink a beer at my desk, and that was no problem. We had a beer fridge, so.
Nice.
Yeah.
That's interesting. I mean, obviously, I've never had a job like that because I was taking care
That's
of
true.
humans.
At a hospital, not the best bet.
There we go. So one of the things that you could observe in the first video, in the top one, is that when the main agent is speaking, it was them speaking, the interlocutor kind of sometimes nodded, sometimes moved their wrists into a mimicking position compared to the main agent speaking. And in the second video, you can observe kind of like how the main agent gesticulates, the interlocutor kind of moves, but not really, and sometimes nods. I might just skip the sound part.
Now she's like back again, like she's like
yeah. So basically, you get the idea. I mean, you talk to people before. So basically, we try to match wrist and head movement, and we in general try to exhibit mimicry with a slight delay because we need to process the information that the person talking to us is providing. So based on this, the idea was, okay, since basically the speaker behavior is like that is something we need to generate. For listener behavior, we kind of don't need to generate our very own, groundbreaking gestures, but we can kind of sometimes perform mimicry or just nod movements at the right times, things like that. So because of the simplicity of the listener behavior, why don't we just take basically the monadic baseline that was adapted to dyadic and just train two models. So basically, that's where our research into this exploration of how can we train two separate models started. So we first, in the training level, identified when the main agent is speaking or listening, took that data, basically, all the encodings that the IVI baseline provided, so MFCC, prosody, fast text encoding, etc., and then trained two models. And then on inference time, we basically based on mostly the audio and also the text extraction. Thank you. Transcript. We decided who is speaking. And then based on that, we just applied the correct model at the time. Then we stitched it all together and we produced kind of like a test output that the guys could test. So as for results, basically, we all know the procedure. So we measured human, or they measured human likeness. We both measured human likeness, monadic and dyadic appropriateness. We trained and tested and validated. The validation was not very necessary at this stage. Only talking with hands dataset. So as for the results, for human likeness, We are SD, which is not highlighted there because we are deceivingly in the middle of the pack. So somewhere there. So you see that we are not significantly better than most of the teams, and we are not significantly worse than most of the teams. So we are kind of like there. However, when you compare to the monadic and dyadic baselines, you can see that our performance was not hindered by essentially training with less data than the previous baselines, because since we filtered to only training with speaker behavior and only training with listening behavior, we kind of were worried that basically our performance would drop in at least the human likeness and the monadic appropriateness cases, even if not in the dyadic one. So once again, you see no significant difference, essentially. Same for the dyadic appropriateness. But what we took away from this is that human likeness-wise, where is it? Yes. So our generated gestures are not quite natural. They are not super good. But when we talk about the listener behavior, sometimes the agent tries to do some sort of back channeling that looks remotely natural, although not quite still. So I would say that was kind of just based on our subjective observations on the generated videos. The takeaway from the whole thing is that, okay, we worked with less data essentially to train the models, and the speaker behavior did not improve, but the listener behavior kind of did, just a bit. Yes. However, we can also say that since no significant difference to most of the teams, the role-based training is just in itself not enough, but it kind of makes sense because, for instance, when we generate gestures for the speaker, it might be enough to just use the monadic way of gesture generation because the interlocutor will need to match your gestures and not vice versa. So maybe at the end, we can also play with the features to kind of not take into account the interlocutor's inputs when we are generating the gestures, because their inputs in that sense are sort of a feedback or reflection of our outputs. Kind of complicated. And as for dyadic, you saw that there was no improvement. However, if we would train a specific model, like design a specific model structure, and tune it specifically for that model, then hopefully we would see some improvements. So basically the takeaway from this is that even though we use the exact same model structure with the exact same parameters without hyperparameter tuning, there was no decrease or significant decrease in our performance. But there's a hope that for the listener behavior, the separate models would be useful. Yes, I talked a bit about the features, and so the reason why I keep saying is that we started working on stuff is that the idea is that now that we can see that, okay, it might be worth looking into different speaker and listener behaviors. We apply the same concept with the talking with hands dataset, but also our own LISA dataset that Tuyen made. With conditional GANs and also diffusion models. And the reason why I asked like two things about PQA is because we also experimented with those recently. And it's like, yeah. Yes, thank you. Any questions?